Hyperbolas. Let's start off with this. So this is your rectangular hyperbola in terms of equation. Notice I used f of x. The reason why I'm using f of x is I want you to get used to that notation. It's the same thing as your y. Okay, so y equals 1 on x, or think of it as f of x equals to 1 on x. Okay? Now, let's just quickly do a sort of a table of values so you can visualize what the graph will look like. So I just chose from 0, starting from the center, negative numbers, negative 1, negative 2, negative 3, to negative infinity, and then 1, 2, 3 to positive infinity. Yeah? Let's think about this. If I had x equals to 1, so if I sub x equals to 1 into my function, so f of 1, what would f of 1 give me? 1. And then if I sub 2, half, 3, a third. So what's happening to the numbers? I started off at 1, then I went to half, to a third, then a quarter, then a fifth, then a sixth. What's happening to the value of the numbers? What's really happening? Yeah, it's getting closer and closer to 0. So it's getting smaller and smaller and smaller. So I'm going to write over here, very small, getting smaller. Okay, so what you expect is as you approach infinity, as you get really large in the denominator, 1 over infinity is approximately 0. It's getting close. I should write here, approaching 0. So it's not equal to 0, it's approaching 0. Okay? And then let's have a look at the negative direction. If I had negative 1, that would give me negative 1. Negative 2 will give me negative 1 on 2. Negative 3 will give me negative 1 on 3. And similarly, it's now in the negative direction, but it's also still getting smaller. The value is still getting smaller. So you'd say this is now approaching 0. So in both directions, it seems like you're approaching 0. So that means if I draw my x-axis, it means it's starting at 1, at 1, 1, and at negative 1, it's also, sorry, it's the other way, it's negative 1, so down here. It starts there, but we say that it approaches 0, so it's approaching, 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 approaching 0, whereas on the negative side, it's approaching, approaching, approaching 0. That's what we're seeing so far. I guess the next question is, well, what happens when it's 0? What's 1 over 0? Undefined. So there is no value here. So it's undefined, there is no value right at 0. So the question is, well, what's happening between negative 1 and 1? It's an asymptote as well. But let's have a look. Let's choose a number that is between negative 1 and 1, but not 0. Okay, let's choose a number. Let's say half. If I had x equals half, then it will become f of half, which is 1 divided by half. And what's 1 divided by half? 2. How many halves in 1? 2. So that's interesting. Then what if I did f of a third? 3, because 1 over 1/3 makes it 3. Then if I did f of a quarter, so you see as I'm choosing numbers, I started off with half, it's about there. Then I went to a third, it's about a bit more than that, and then a quarter. Then I can go to a fifth, a sixth, a seventh, but what you can see is a fifth will give me 5, a sixth will give me 6, a seventh will give me 7. So what's happening to the numbers? As I'm getting closer and closer, if I chose numbers close x values closer to 0, what's happening to the values? Increasing. And that's the thing is, it's never going to be 0 because we know at 0 it's undefined. But we do know that as I increase or decrease the value of x, it actually increases my y value, but it has an asymptote, as Jamal was saying before, at x equals 0. There's an asymptote there. But at the same time, there's also an asymptote horizontally at y equals 0. So we can see is this is your basic graph that I'm sort of drawing right now. That's your rectangular hyperbola. And for those who's doing spesh, you'll notice it's very similar. The asymptote that you get with spesh was more of an x, and this is still an x, except it's perpendicular. Okay, it's right on the axes. Yeah.
Why is the 0 over the x-axis?
Because we said as you approach 0, so as you approach infinity, this number is approaching 0, but it's never equal to 0. Because you can always have 1 over something, and it's always a small number, so it gets very small, but it's never equal to 0, so therefore you have and approaching, or we call it asymptote, which means it approaches 0. And because it approaches 0, it's approaching y equals 0. This is approaching x equals 0. Does that make sense? Yeah. Okay. So these are my properties of a hyperbola, and that's all you're really taking in. And then after that, what are you going to do is you're going to apply everything I taught you in quadratics to move it up, down, left, right, thin, wide. Exactly the same thing. All you had to understand was why this shape looks the way it does. Properties, asymptote at y equals 0, asymptote at x equals 0, and this is your shape. So then I can show you, when you move it left, right, what affects, what you need to look at and what it affects. And then that's exercise 4A. Simple. And once you understand 4A, 4B, 4C, 4D are exactly the same. They follow the same drill. Yeah? Now, I'm just going to rub this all off so that you can see. And for 2, I was just testing so you can see it's half, and then that becomes 2, that's negative 10, and that's a really small number. Okay, now, that's everything that I was just saying before, and this is what the graph looks like. I don't know why there's sound effects. I must have put it ages ago. So this is what it looks like. Does the graph look like our predicted graph? Yes. Okay, cool. Now, this is where we get up to. So I said before, this is your general graph. F of x equals 1 on x. Yeah? What have I changed to it? I've added an a. I've got an x minus b. And I've got a plus c. Now, if I just try to show you how it's similar to your quadratics, you see a is what you're multiplying to the equation. So it's a times 1 on, and this is your bracket. This is where I'm putting my bracket. I'm going to use h now. So it reminds you of x minus h squared, and then plus k. See how in quadratics, and I'm going to write out the quadratics equation so you remember, it was a bracket x minus h squared plus k. Yeah, this is what we learned in quadratics, and even in cubics, it was the same thing except that was a cube. And we said a is what makes it thinner or wider. That's the same thing with this one. See, a is being multiplied to the quadratic function. K is the separate number that is added on or subtracted. This will tell you up or down, and there's no difference for this one too. This one will tell you up or down, just like here. That's a separate function you're adding on, so that's up or down. If you want to know if it moves left or right, you play around with the x. See, this is, normally you have f of x equals x squared, but because you play with the x, so that's the x minus h, when you play with the x, you're moving it left or right. When it's the outside, that moves it up or down. So if I look at this one now, the c, this tells me up or down, just like we've always been used to. Positive is up, negative is down. If you want to know if this moves left or right, what did I teach you? What did I say? What did we do? Good. Let it equal to 0. So x minus b, let it equal to 0 and solve for x. If it's positive, it's to the right. If it's negative, it is to the left. Okay? So that's what we know. And then a is a dilation. Tells you whether it's thinner or wider. Yeah, so thinner or wider. But at the same time, I also told you if it's positive, it stays the same shape. If it's negative, we flipped it. Remember with the quadratics, if it was like this, every y value gets flipped if it's negative. Yeah? It's the same thing with your hyperbolas, rectangular hyperbolas, they'll be the same. If you put a negative on it, it flips. And it just becomes the other way around, so it'll look like this. That will be the negative version. Okay, so you're flipping it because the original version was like this. So this will now flip down here, and this one will now flip back up. That's your negative. Negative 1 on x, and this is your 1 on x. Okay? Now I'm going to play with GeoGebra so you can see what I mean, and hopefully you're picking up. The things that you learn in quadratics and cubics is exactly the same for your hyperbolas. Okay? The mathematics is much easier to find out x-intercept, y-intercept, no factorizing now. So you don't have to learn any new skills, you're just doing algebra. That's why chapter 4 is much easier than quadratics and cubics, because you don't need factorizing. You don't need to know null factor law, you didn't need to know, anything to cross method, difference of perfect squares, completing the square, factor theorem, none of that. It's now just the shape of a graph, Transformation, x-intercept, y-intercept. Simple as that. Yeah? Now, let's have a look at GeoGebra just so you can get your head around, not this one, this one. All these other functions is for the next exercises, and in this one GeoGebra, I can show you just by changing A and B, it does the same thing for every single graph, because whatever you're learning quadratics is applied to every single graph that you can think of. It's the same thing. All right. So right now, today we're just going to focus on P. P of x is 1 on x. Okay, we're not going to do this one. That's the next exercise, and then you got rid of x, and I'll show you all that later. Okay, so we're just going to focus on this one here. I'm going to make it larger so that you don't get confused by. Okay, so we're going to focus on the 1 on x, nothing else. Okay, let's focus 1 on x. Now, I said if you change the a value, that should make it thinner or wider. So let's test it. I'm going to change my a, so if I change that to a 2, what I want you to see is, wait, where's the 2? All right. You see the 2, what you're actually doing is you're multiplying every one of these values by 2, you're doubling it. So from here it goes 1, 2, everything here gets doubled. That's why it's stretching up. Okay? And the same thing here, whatever the values are, you're timesing it by 2. So the larger I increase this, the more stretched vertically it becomes. Okay? So if you have a look at that, I'll increase A, and I want you to see how it's stretching up, because you're moving it away. Okay? Now, if I made it smaller, if I made it half, so if this is 1, so this is 1, wait, where's 1? Come on, okay, it's 1. Now if I made it smaller than 1, between 0 and 1, you should see that all these values should now be halved or third. You're taking every coordinate and you're halving it depending on what you're multiplying it by. Because you're multiplying this by half, then you're halving every y value. So if you watch, if I change this to a half now, I change it to 0.5. So that value at 1, it should have been 1, 1, now it becomes 1.5. So 1/2. So the y values are all half. So every term now gets half. And if I keep decreasing it, you should see it gets closer to the x-axis, because now you're making it a quarter. And that's about a quarter. It's about a quarter. Yeah. So that's about a quarter there. The question is, well, what happens if you then get into the negative side? So once you go to 0, obviously it's 0. That's why it's just a straight line. But then when you go to the negative, yeah, it flips. But the value is still the same. You see, like it's 0.5, so it's still thin. It's still close. But as soon as I increase that to 2, 3, even though it's negative, it's just moving away. So all these values are multiplied by 3. It's multiplied by 3, but flipped. So multiply by 3, flip. That's what the negative does. Okay, so I'm going to just move this across so you can see. So that negative flips it. The 4.25 is what I'm multiplying to these values. 4.25, so 4 times up, and then flip it. That's what's happening to it. Okay. Now, I said the left and right. So if I change this back to 1, we're going to go back to 1 again, so you can see B is what oh, actually no, we're not talking about that stretch. This is a different type of stretch. I'll talk more about it when we do transformations. Here we go. So what I want you to see here, if I increase these values, that's +2. The technique I taught you before was I said, whoops, not that one, this one. Whoa, it's delayed. Okay, here we go. I said let that equal to 0, solve for B, and if it's positive, it moves to the right. If it's negative, it moves to the left. So, we go back to this graph, that's an x +2. So if you solve for this, x will be -2. So you can see the graph has moved to the left by 2. There's an asymptote at -2 right now. Okay, so that shifts it left or right. So if I just move it left and right, increase left and right, you can just see it just depends on what number I choose, and that changes the asymptote, the vertical asymptote. Okay. If I want to move it up or down, see, up or down would be the value that I add on to it. So if I just change this back to 0, see if I add 2, it just shifts the graph up by 2. The asymptote now is at 2. It will never touch 2. So that's why you can apply whatever you learn in quadratics and cubics, you can apply it here. Does that sort of make sense so far? Yeah? All right, so let's do a quick example. Let's have a look at what you can, whoops, all right. Here we go, let's read this one. I know I just gave the answer, but what's the answer for this one? Y equals 1 on x minus 1. This would do what to the graph? Good, it moves to the right by 1. So you let this equal to 0. So x minus 1 equal to 0, x equals positive 1. So it moves to the right by 1. So what does the graph look like? Because it moves to the right by 1, the asymptote now is to the right by 1. So it's at x equals 1 instead of 0. And the shape is still the same. Okay, that's my graph of x 1 over x minus 1. Let's have a look at the next one. What about this graph? Y equals negative 1 on x. What does that look like? What would I have done? Flip it. So this graph here, everything still stays the same. It's still x equals 0 asymptote. Still y equals 0 asymptote. The only thing that's different is the other direction. Let's have a look at the next one then. What about this one? 1 on x plus 1. What does that tell me? 1 up. So how does it look? If this is your normal graph, asymptote was y equals 0, then now you're shifting it up. So the only thing that changes is your y asymptote, so y equals 1. But the shape stays the same, so it's still like that. And you're done. So now, what's so difficult about this shape? Remember, it's a 3-mark question. Axis intercept, asymptote, and shape. So you got your shape, that's 1 mark. Got your asymptote, 2 marks. Okay, your 3rd mark, find your axis intercepts. Now, axis intercepts has always been, if you want to find your y-axis, let x equal to 0. Want to find your x-intercept, let y equal to 0. That's the only thing you have to add on. And suddenly, you've mastered 4A. You do the same thing for 4B, 4C, 4D. It's all the same thing. You're doing exactly the same thing. I'm going to show you in the next few sessions. You're going to see whatever I'm teaching you now, add, left, right, up, down, is exactly the same for every graph. That's why if you understand one, you understand the rest. Okay? Let's have a go with a couple of questions. Let's see. It's your turn, actually. Let's go with these ones. It's your turn. You got 5 minutes. I want you to roughly sketch. Don't find the x-intercept yet. I just want you to label asymptote and shape. So get 2 out of 3 marks for now. Okay, so out of these 3, I want you to do it in 5 minutes. Roughly sketch. Is it moving left? Is it right? Is it flipped? I want to know what the graph looks like. Asymptote and shape.
That's the normal one.
Keep some harsh strength.
When you're surrounded by people who are so dumb.
I feel like I should take his approach. I have many people as I'll take. You're right. And the animation section. That's a bit odd. He's down. As you can see here. I used to put music, and so every time it moves like the slide, I'll time it. So I edit the music, and I edit the timing as a transition. So it will move as the music is finishing and start transitions. It just took so much time, so I was like, no, I gave up. But there was a time where I did it. Maybe my last session on this one. I added some pretty epic music in. We like a cinematic PowerPoint.
And you still want that. No, you did it that way, yes, like.
All right, let's have a look at your answers. Once I get my change of color. Here we go. First one. Name me one transformation that you can see. Let's go. Yeah, Renata. It's upside down. So yes, it is flipped because it's got the negative. So flipped. So I already know that the graph looks like this. Okay. Next one. What's another transformation? To the right by 2. So this here tells me right by 2. And that only changes the asymptote, vertical asymptote. So it's moving to the right by 2. So I draw the dotted line. Remember to label your asymptotes. This hasn't changed. Horizontally still y equals 0 because I haven't moved it up or down. It's still that. So that's my asymptote. And I got my shape. So here we go. Just draw so that it doesn't touch those lines. So now you know there's a y-intercept that's positive and an x-intercept that's greater than 2. Yeah.
Instead of writing out those, you just put the dot in the middle and say to show.
Like here and write 2. No, must do the dots. Yeah, I know.
No, as in not, no, do the dots, but like put a dot in the middle, then write 2 over.
You got to write the equation. Yeah, so that's how the proper way of writing it. You got to write the equation with it. So write the equation of the asymptote. Next one, B. So I'm just going to take this off so it doesn't confuse you. There you go. B. Name me one transformation, Chelsea. You flip. Good. There's that negative, so it's flipped again. So we know that the shape looks like this so far. What else? Name me one more. Yes, Shinjun. Oh, not Shinjun. All right, Jun. Up by 3, good. Up by 3. So have you, oh no. There we go. Up by 3, so because it's up by 3, that means you only change the horizontal asymptote, y equals 3, but the vertical asymptote is still the same, so it's still 0. Okay, and the shape is flipped, so it looks like this. There you go. And the last one, this one's a bit trickier. Jamal, name me one. Moves up by 1, so this is up 1. Name me another one. Can I please have Ian? Yep, left by 3 units, good. Left 3. Bruce, oh no, Bruce is doing his thing. Elliot, name me one more.
Sorry, say that again.
Name me one more transformation. So we got up 1, left 3. It's negative, so it's flipped. And because we're drawing a graph, there's no point of really drawing the dilation. No one can tell. Unless you're drawing 2 graphs, then you can show that it's thinner or wider. So in this case, it doesn't really matter. The 2, we know it's a dilation, but you can't really draw it. So let's put it all together. So left by 3. So I'm going to draw my asymptote. Left by 3, x equals negative 3. Up by 1, so up by 1. So I do y equals 1. And it's a flipped graph, so it looks somewhat like this. Now the only way to draw it accurately...
It's still working on the negative sign.
Alright, well I'll just wait. It should magically pop up eventually. X equals negative 3. Y equals 1. And then that's your shape. Come on, last bit. Almost there. I think it froze. Couldn't handle the graph. Anyways, here. The reason why I'm getting you to read the transformation is because we don't know. We know this is the shape of the graph, but what we don't know is where the y-intercept is. Because if it's negative, then it'll cross here and it'll cross there. If it's a positive y-intercept, then it'll cross up here and it goes across. So that's why it's important to find out your x-intercept first, y-intercept second, and you've got a rough idea what the graph looks like, then sketch it. Okay, because I could be sketching it wrong right now. I don't know if the y-intercept is actually positive. It could be negative, and this doesn't make sense. Okay, so how do we find out the y-intercept and x-intercept? Let's just say I got, you know what, I'm going to do a texter now. I'm going to texter. I have a texter. Yes, I do. All right, last part of it, let's just copy that one. Y equals to 1 minus 2x plus 3. Yeah? Finding y-intercept is the easiest. How do you find the y-intercept? What do you do? Let x equal to 0. So we're going to let that equal to 0. You've got y equals to 1 minus 2 over 0 plus 3. Yeah, that's the find your y-intercept. Let x equal to 0. Okay? That makes it 1 subtract 2 over 3, 1/3. Okay, so that means I happen to draw it correctly, that y-intercept is at 1/3. So y-intercept is at 1/3. Like this. So I know the y-intercept now is at 1/3. And the graph looks like that. X equals -3, and then y equals 1. Yeah? Now the only thing is I need my x-intercept. How do you find x-intercept? Let y equal to 0. So x-intercept, let y equal to 0. So you've got y equals to 1 minus 2 on x plus 3. 0 equals to 1 minus 2 on x plus 3. Okay, now the only reason why this might be tricky for some is because it's got a fraction. It looks like a fraction, but you're really just going back to year 9 and 10 mathematics, rearranging the equation. So here, I've got a positive 1, and say subtract 1, subtract 1. That gives you -1 equals -2 on x plus 3. I know this is two negatives, so it would be easier if I just said divide by -1, or times by -1, times by -1. Two negatives become positive. So now I've changed the equation to 1 equals to 2 on x plus 3. Now what do you do if you have a fraction like this? What's the technique I taught you? I said every time you have a fraction, a denominator, you don't like it, what do you do? Yeah, times by whatever the denominator is, because this is saying divide x plus 3, so the inverse is times. So if I just said times by x plus 3 on the right hand side, then I can now say times by x plus 3 on the left hand side. Okay? And over here, conveniently, x plus 3 divided by x plus 3 is 1, and you're left with 2 equals 2x plus 3 times 1. Now, this is nice because it's equal to 1. Sometimes not equal to 1, then you have to sort of divide it and get rid of it, or expand it, then bring it all across. At this point, because it's nice and easy, you've got x plus 3 times 1, which is x plus 3, and suddenly solving for x must equal to 2 subtract 3 is -1. So this point here is -1, 0. Okay? And you get your full 3 marks. Shape, asymptote, axis intercepts, 3 marks. Yeah? Easy 3 marks. So what was the hardest one was to read the graph, know the properties, and this is just simple algebra. Finding y-intercept is the easiest. X-intercept, maybe the fractions will get some students. But other than that, you're not factorizing. You don't need to know any theorems. You don't need to know any cubic division or anything, none of that. None of the basic skills. Now it's just going back to year 7, 8, 9 algebra with fractions and reading transformations. The only thing I taught you new for year 11, but you had quadratics and cubics to do. That's why chapter 4 is easy. 4A, 4B, 4C, 4D will follow the same sort of drill. You just get different graphs. Cool? All right, excellent. We'll leave that there and do all questions of 4. I want you to sketch them all with the y-intercept. If you can solve for the x-intercept, do so. If you can't, at least you get the 2 out of 3. Get your 2 out of 3. So you get your shape, get your transformation asymptotes correct, and then the x-intercept will work on that as your algebra improves. Yeah, but for now, just learning how to sketch it by reading the equation of 4A is what I want you to do. Okay. Oh, it's not coming up. All questions. 4A, all questions. Size 4A, all questions. I'm going to...
So is it x, 1x and y or b1?
No,